Hi, we are looking at question number 3. This appeared in the physics paper 1, CIE March 2019, subject code 9702. Let's read the question. The speed of an aircraft in still air is 200 km per hour. The wind blows from the west at a speed of 85 km per hour. In which direction must the pilot steer the aircraft in order to fly due north? So what are we given? We are given the speed of an aircraft in still air. So that will be before that, right? Let's just talk about the notation I'm using. A is aircraft, W is wind, and A/W is aircraft relative to wind. So from this line here, okay, the speed of an aircraft in still air is 200 km per hour. We know that the magnitude of the velocity of the aircraft relative to the wind is 200 km per hour. Again, the magnitude of the velocity of the aircraft relative to the wind is 200 km per hour. That's what I've written here. And we're also given the velocity of the wind blows from the west at a speed of 85. That's what you see here, the velocity of the wind, 85 from the west. And we want to fly due north, so the velocity of the aircraft is due north. Good. So what are we trying to find? We are trying to find the direction of the velocity of the aircraft relative to the wind. Again, what are we trying to find? The direction, in which direction must the pilot steer the aircraft? So we are trying to find the direction of the velocity of the aircraft relative to the wind. So this is your relative velocity equation. Let's just use A and W, okay? The velocity of A equals the velocity of A relative to W plus the velocity of W. Now this is the relative velocity equation. You can also write it like this. This is a vector equation, yeah? Vector VA equals to vector VA minus vector VW, which is one vector, plus vector VW. Okay? So this thing here is vector A/W, the velocity of the aircraft relative to the wind. Good. So this, by looking at this relative velocity equation, we know we are dealing with a triangle of vectors. This is your resultant, and this will be the two vectors that we need to add in vector form to get this vector. Okay? Good. I've given you a solution here. You can look at it. Let's just talk through the problem, yeah? We want to fly due north. Let's just draw a picture here. Okay? We want to fly due north. And we have a wind from the west. Okay? We have a wind from the west. So this is the wind. This is the aircraft. So again, we want to end up due north, and we have a wind which is from the west. In what direction must we set our aircraft again? In what direction must we set our aircraft so that we end up due north? That's basically what we're trying to do. Okay, in what direction must we set our aircraft so that we can end up due north? So what we can do is we can set our aircraft in this direction. This will be A/W, and let the wind blow this way, and we end up this way. Okay, so we have a triangle of vectors here. This is your resultant. Okay, resultant, vector VA. Now this is the vector VA/W. This is the direction in which we set our aircraft, so that with help from the wind, okay, this one here is velocity of the wind, we will end up due north. That's the logic of it. Now, we are looking for the direction. So basically we're looking for this. Let's call this alpha. You know this one here is 85. This one here, you know the magnitude is 200. So we can write from this triangle here, sine alpha equals to 85 over 200. So use a calculator and you will get alpha is equals to 25.2 degrees. And that will be west of north. Therefore, correct response D, 25.2 degrees west of north.